In this video, we're going to learn all about something called complex fractions. These are types of fractions where you have fractions inside of the fractions, or you might think of it as fractions in the numerator and fractions in the denominator. So in the most complicated example, you'll have fractions in both, and we're going to be able to simplify them. So what is our first step? Well, you're going to combine any fractions that are in the numerator. Then you're going to combine any fractions that are in the denominator. Now, since it's one fraction divided by another, you'll be able to rewrite it as a multiplication problem. Multiply across and simplify. So this makes the most sense in practice. So let's try this problem. 1/2 plus 3/2 all over 2/5 plus 7/5. I need to start by combining the fractions that are in the numerator. So 1/2 plus 3/2. Notice that what I'm really doing here is I'm doing 1 plus 3 over 2, which is 4 over 2, which simplifies down to 2. So those two fractions in the numerator are really just 2. So I'm going to replace those with the number 2. Then I'm going to combine the fractions in the denominator. So 2/5 plus 7/5, I can think of as 2 plus 7 over 5, or 9/5. That doesn't simplify, so I'm going to go ahead and replace the denominator with just 9/5. Now, I'm going to rewrite this as a multiplication problem by keeping the 2, changing to multiplication, and flipping that bottom fraction. 9/5 becomes 5/9. Now, I can just multiply across. 2 is really 2 over 1. So this is 2 times 5, which is 10, and 1 times 9, which is 9. 10/9 is my final answer. That looks much simpler than what we started with. Now, in that example, all of our denominators in the numerator were the same, and the denominators in the denominator were the same. But what happens if we have all different denominators? Does it change the problem? No, actually, it stays exactly the same. So we'll combine the fractions in the numerator, 3/5 minus 1/2. But they don't have the same denominator, so I need to make them have the same denominator. So in this case, I'm going to multiply the first fraction by 2 on top and bottom, and the second fraction by 5 on top and bottom, so that they have the same denominator, 10. I'm going to now have 6/10 minus 5/10, which is 6 minus 5 over 10, or 1/10. Now that I've simplified the numerator, I can replace it with that 1/10. And now I'll be able to simplify the denominator. 1/7 plus 4/5. Well, the common denominator here is 35. So I'll multiply the first fraction by 5 on top and bottom, and the second fraction by 7 on top and bottom. When I do that, I end up with 5 over 35 plus 28 over 35. When I add the numerators together, I end up with 33 over 35, and that's what I'll replace the current denominator with. Now I can rewrite this as a multiplication problem. Keep the top fraction, change to multiplication, and flip the bottom fraction. So that 33 over 35 flips to become 35 over 33. Now I can multiply across, and 1 times 35 is 35, and 10 times 33 is 330. To simplify this, I can divide both top and bottom by 5, which gives me 7 over 66 as my final answer. And that is how you simplify complex fractions.